So where did some of these myths come from? Well, there are several reasons that we have all these northern myths. Because now if you are a grad student, you are a junior faculty, and so on, you have to publish or you know where to go, right? But then if you have established yourself a little bit and you just say that, okay, I want to be a full professor, you still have to do that. And beyond that, I want to build my empire. Some of my colleagues do that, right? I am the authority of whatever that is, right? You have to keep on publishing, right? After a little while, you find that you have to publish something which the newspaper wants it, or science wants it, or nature wants it, right? So you could be starting with notes, which is easy to do, just 2 pages, no more. And then you start exploring it and becomes an article. Then you get even bigger, become monograph, and finally, you do something silly, like writing books. The bigger it is, the more myths you can create. So, as when I was at high school, I learned Shakespeare. It says, blow, blow, thou winter wind, thou art no more unkind. And then after that, I said, as the myth of the North, which some scientists have put forth. So that's my contribution to shaking the spear, right? So, so some of them possess the element of mythology. And what do I mean? What do I mean by myth? I haven't defined it yet. In science, you don't define it. You don't know what you're talking about. Not that I know what I'm talking about, but I have to define it anyway, right? So in my presentation, which is about scientific myths, in this context, I would say it's a myth is a story that is treated as a true account of how natural phenomena came into existence. There are some elements of truth in that. If there is no total, if it's a total lie, you could just say, this is BS, right? But if you got a little bit of truth and the rest is imagination, that makes it enticing, and therefore it becomes a good myth, right? You don't know what I'm talking about? Listen to the politicians, some of them. So I'll use some examples tonight. I'll go through snow, rock, climate, stream flow, permafrost, and finally, I just get beyond my level of knowledge and talk about myths in people-related scientific research. Okay? 1970, in the beginning, there were scientists, there still are scientists at the beginning, right? And they say that the Arctic is still called it polar desert, but they say that it's not that much snow, just a little bit of snow whirling around, the wind picks it up, redistributes it, and that's about it. Really, it's not that much snow. Okay, I agree with you. But why do you say so? Because the weather station tell me so. Right. So there's the old weather station at Resolute, and you measure the snow in here, and notice this is the Resolute airport. Now notice, of course, that these areas are windswept. I asked my friend in weather office, why do you choose a windswept site? He says, we have a reason for it. I said, you know it's not very good for catching the snow. He says, I don't care about catching the snow because, just back to history, not myth, real, the old climate office is part of the Department of Transport, in case you know the history of the Canadian environmental services type, right? And they didn't care about the snow, they care about the snow for flying. So how much snow you have really, for hydrologic purposes, is irrelevant. They just need to know how much snow there is at the airport, right? So, okay, we take those numbers. Scientist says, you measured it, must be true. So we take those numbers. Okay, sorry, I've got to do a bit of science. It says myths in northern science, a bit of science. This is very easy science, right? So this is how much precipitation you measure at the weather station, 157 millimeters. And you measure the stream flow, right? 162. And you know there is evaporation going through, right? So All the water comes in from precipitation, and then you lose it to stream flow, lose to evaporation. Lo and behold, there is something very interesting. There is water from who knows where, because this amount that we receive is much less than what you have to spend. But you can't do that in hydrology for long. You could do that for a while. Glaciers allow you to do that. You store it and release it. But this is no glacier, right? So what's the problem? The problem is that this number. Now, Kathy did not really explain what happens, but let me explain what happens. It's very obvious where the snow comes from. They blow and blow. They didn't go blowing around and around. When you get gullies and depressions and so on, they accumulate. So in fact, if you measure how much is accumulated in the valleys and gullies and depressions and so on, amazingly, the value is 212, which is sufficient for this and that. So, in fact, if you believe in the instrumented numbers and so on, without really thinking and looking around, you are listening or believing in some of those myths. You all know the stories, right? Several blind people. What's an elephant look like? The elephant looks like a snake. The elephant looks like a tree trunk. The elephant looks like a wall. The elephant looks like a rope, right? You know what the elephant really looks like. A lot of times, you're basing your conclusion, deductions, on insufficient evidence or false premises. What's the elephant got to do with us? Well, there is this elephant in science, and there's a myth. All textbooks in the past, in hydrology anyway, assumes that the bedrock behaves like concrete. You don't believe me? Just walk out, right? When it rains, it's like concrete, pour water in it, it runs off, right? So if the bedrock behaves like concrete, you go and have a closer look. How on earth can the tree grow from the rock, right? So that means there must be water coming in and out through all these areas. The rock behaves like concrete. You pour water in, everything goes, right? So what we call scientifically the runoff ratio, which is the ratio of runoff divided by rainfall, it should be almost 1. Huh? Look at the literature. The ratio ranges from 2% to 60%. What's going on? For some strange reason, for decades, people know these values. They actually measure the precipitation. They measure runoff. And they got these fantastic ratios. And they say, oh, I don't know. Rock should be like concrete, right? So until my brilliant student, I got lots of brilliant students, one of those, and students, one of those, 2 of those, and so on, right? So they come up with these great ideas. Well, just pour some water into a rock. You saw that, right? I don't need to show you anymore, right? So you say, that's trivial. I know that. What's so big deal about it? Well, the big deal about this has got very serious consequences. And this is one of the consequences. The Precambrian shield rock, you know where Cambrian shield is, right? Just go up to Barrie and all those places, and then that's Precambrian shield, right? You think they say it's watertight. And if it's watertight, you could put toxic materials into the bedrock tunnels, then it would keep, and problem solved, right? Right. This was the gold mine, giant mine in Yellowknife, right? They've been putting the tailings into those tunnels and other things in the Precambrian bedrock. Now, they found out that in fact, the rocks have cracks. That means you got groundwater coming in. The groundwater can bring these toxic materials somewhere else. So, as you can see, over the years, they have arsenic. They use that to to treat the ores and get the gold and so on, right? So you got arsenic. And you got so many tons, right? 250,000 tons of those stuff inside the rock, deep down. You don't know what to do with it. You can't take it out. You can, yeah, you can. You bankrupt the country, yes, right? Or what they do now is to say, let's freeze it, because this at least is a permafrost, this continuous permafrost areas. What if it warms up, right? If I know what the answer is, I'll be rich. Since I'm not rich, I don't know the answer, ergo, there's no solution. Right? I have to talk about climate change to an audience like this, right? Because if I don't talk about climate change, then you say, what kind of scientist are you, right? So, okay, so I talk about climate change because one of them is me, not this. I'm not as attractive, but it might be one of these hanging on and just do the climate bandwagon, right? And in climate change, it is very trendy to study trends, right? Well, whatever that means, right? So let us all examine some trends that the climatologists have proposed, right? Right. This is a very, very important publication to the Arctic scientists. It's Arctic Climate Impact Assessment publication, 2005, right? And this is Canada River, which is close to Fairbanks. And this is the ice breakup, the date when the ice in Canada River breaks up. Of course, what you see here is that this is the date of year, right? This is like 120 would be divided by 3, is like April 1st or something, whatever. I can't divide, May 1st. Anyway, right? So what you can see here is there is a trend of getting warmer, and therefore the breakup on the average, if you look at the trend, is getting earlier and earlier because of climate warming, right? And it started in 1920, right? The line tells you so, right? You like to fit your line? Really 1920? I don't know. I would say that part is rather flat. Yeah, huh? No, you don't have to agree with me. We're just building myths together anyway, right? So whatever you like to say, that's fine, right? I would not draw a straight line like that simply, right? A fluctuation, yeah, but you draw a straight line. You know why you draw a straight line, don't you? We all have Excel, don't we? Okay, so let's look at the temperature. Mean annual temperature at Hay River, which is, in case you want to know where that is, it is northern. Why is it northern? It's north of the 60s, right? So it's got to be northern, right? Well, that's by definition, right? You say the climate has changed. What is the temperature like? Go to Excel, it helps you, it's very easy. But that's not what you do, right? It looks more like this, doesn't it? Right? I would say it looks like this. But you still do Excel. Right? Better than that, you could actually use statistics. There is this thing which nowadays is very popular in the last decade. A lot of scientists use the man-candle test. Okay, but everybody uses that, and being part of the myth, I have to use that. We have to use that, right, Robin? So he calculated this. It's a set score of 4.6, which is highly significant in a straight line like this, right? Isn't that wonderful? Now, why do I say it should be like that? Because we publish paper with this, right? Therefore, what I say must be truth. What they say must be myth, right? Well, no, not because of that. We'll say that there is a big jump in this. Look at 1975. This is particularly important. We have, just have a look again, right? Just have a look again, right? So remember what I said, oscillation, straight line, or step jumps, right? I would prefer step jumps because if we just take 1975, and look at the climate. British Columbia, the north, right? Yukon and all that, right? And this is just the winter conditions. And these are the pressure gradients, right? The difference in the pressure field between two periods, before 1975, after 1975. There was a significant shift in the pressure pattern, which means that the airflow and everything has shifted, right? That means, which I come to later, our old friend El Nino, the Christ child, La Nina, which is what the Australians like now to get rid of, right? Which is this year, and so on. And that has undergone a major shift. So if there was a major shift, I believe more in that and draw two lines, one like that, with a sharp break in 1975. And if you do the proper statistic, not the silly man-candle test like that, but change point and all those, you actually find that there is significant break in the data, which means that you should cut the data into different groups, right? So that's why I would prefer this, because it has got the backing of the atmospheric sciences. I've said that people like to draw a line through and say that there is a trend, but it's not that simple. It's not a simple trend. And that's where the newspaper tell you that there is warming. Ha ha ha, how come we're getting so cold in Europe? There's no warming. These are what the reporters like to say, right? That's just, okay, you have expressed your ignorance with fluency because you don't know and you just buy the myth, right? So let's look at this thing, which is El Nino, right? And this is Callao, which is the port of next to Lima. And outside that, that's where the El Nino stuff come from. These are the fishing boats, and for centuries and so on, these people found that if you have El Nino condition, the fishing is going to be different from non-El Nino, and so on. And so we find that this is not a trend, this is a variability, which means that sometimes it's high, sometimes it's low, sometimes it's warm, sometimes it's cold. So now we find that spatially in Peru and so on, it is rather dry. Australia is very wet because La Nina is happening, right? When the El Nino year comes, it's the opposite, right? So it's not a trend like that, but there are spatial variations, right? If we look at the increased carbon dioxide concentration together with methane and other greenhouse gases and so on, it would change the whole dynamic of the atmosphere. And more than just the atmosphere, there's also the water and the land, of course. But water is far more important because it's a bigger body. And water can absorb heat and release heat, and so on. It's a big storage. And water is not like our bathtub. Well, it depends on what you do. You put some ducky, actually moves, right? The water moves, right? So you find that, for example, you could get the wind blowing this way, and you could actually drag the water from the depth into to the surface. And so you got the cold water upwelling to the surface. It warms gradually, and then it might precipitate somewhere on the downwind side, not on the upwind side, right? So this changes. It's not as straightforward, and so the whole Earth is warming. Yeah, on average, yes, I think, right? I might be doing a myth too, but so far I'm convinced that yes, right? But it is not straightforward like everywhere is warming, right? It's very complex because the atmosphere is dynamic and interact with ocean and the land, and everything is on the move. And so if you have a change in the heat and moisture regimes of the Earth, it's likely to increase the spatial and temporal variability. You increase the variability, right? There are variations in the precipitation and temperature field, and it varies from year to year. So we have to take that into consideration. And what is unfortunate still is that we are still those models that tell us about the global warming and so on. Even though it's billions of dollars go into that, it's not sufficiently advanced that they can't even simulate El Nino and southern oscillation too well yet in the climate models, right? So we have to take all these with a grain of salt when you see people saying that there is climate change, therefore you have a warming. So anyway, this is Hay River. Again, it's north, right? 60 degrees plus, right? So it's northern river. And it has been reported in quite a few articles that there is an increase in winter flow. That means there are more flows in the wintertime. The Hay River. Our friend Ming-Ko, oh yes, there are two asterisks, which means it's highly significant, right? And you see that the low flow and winter flow is increasing by 0.3 cubic meters per second per year. Okay, yeah. Would you get something different? Maybe, right? So it depends a bit, right? So, okay, let's accept that there has been an increase in the winter flow. Now, so the question is, why? Why would the river increase the flow in the wintertime? And they've got, the scientific paper have come up with just say, because there's an increasing trend in the winter season in terms of precipitation. So there is an increase in precipitation in wintertime, therefore you get higher flow in wintertime. Makes sense, doesn't it? Look at the mean temperature. Look at the mean temperature in these, just for this particular year. It's and look at, say, 2001 example. It's minus something, minus something, minus something. You get snow sitting on the river ice, and it is not going to increase the flow of rivers just like that, right? So I don't know why they say that, but they say that, and it is in journals too. So there is other explanation which would be slightly better. Now, this is St. Jacques and Sorchen. Notice how they just hedge their bets everywhere. Read what they say. He just proposed that the flow increases due to climate warming via permafrost thaw that enhanced infiltration and deeper path and hydrologic cycle intensification, and so on. So it is a combination. You've got all these things which come into the permafrost, the temperature and precipitation, right, which come into the ground and then have a permafrost thaw a little bit, right? How does permafrost thaw anyway? So let's look at this. This is this continuous permafrost area. Now, it is possible, because in that case, but this is the same, right? And then you thaw it. You don't have to melt the whole thing, because you could melt like this, and you increase the flow. That, I think, is what they're suggesting, which is a possibility. Other papers, they're more mystically oriented. They said permafrost thaw, which means that you're just thawing it, and go down. Yeah, after a little while, you have no permafrost left, and then where do you get extra water come from? They say that's in the future, right? But anyway, so there are all these things which I think is interpretation. So I don't really know what is true or not, but then if you don't know what is true or not, then maybe you shouldn't, huh? Right? Yeah, you saw that? You saw that, right? So now, statistics are not all bad, but you have to use it wisely. Statistics could be very useful, it could be very harmful. And now we are really advanced. It's more than statistics. We have models, right? But if you know models, then you know that in the old days, when you deal with models, it is fairly straightforward. When I was a grad student, model is very simple. And I could understand that. And we could follow the algorithm. Boom, so you put in the water, follow the track, boom, here it goes. There's how much water you have, right? Not anymore. Now, I have no idea where this goes. It just goes up and down, around, and come, boom. This is, believe it or not, don't believe it, don't use a model. Believe it, then you have faith, right? So, this is one thing about models. Do I understand the climate models? No way. And I put it that 99% of the people use climate models don't have a clue what the models is about. So, permafrost, right? That's another thing which I like. So, there's models, which says there's model which shows that the permafrost is degrading under climate warming, right? Yeah, we all know that. One famous paper 6 years ago said that over 2/3 of the existing 3 meters, that's 1.5 of me roughly, permafrost will disappear by the end of this century, right? So never mind this. That means most of the area would have no permafrost. This is where we still have permafrost now, supposed to be, right? And this is where you would have permafrost only at the below 3 meters and no more, right? Fantastic stuff. Wow, in next to no time, less than 1 week, we find that it's the newspaper. This is published in a highly respected journal. Newspaper interviewed this, permafrost experts in the world comment on this, and is cited by newspaper over 100 times within half a year. It's the Arco Tito in Rome, and notice that whoever is on the chariot is now faceless, right? So how do I know, and quite a few of us too, and work in permafrost, know that this is worse than a myth? We ran an equivalent of that model, and we put in Norman Wells. This is the north, by the way, right? Norman Wells, right? It's got permafrost, right? And we ran it from 1970 all the way to 2100, right? This is historical data. We used the real data, ran it, right? So just warm up the model and so on, and then we run these scenarios, right? And we ran into 3 different situations just to cover the possibility. Bare areas, under shrubs, under forests, right? And see what happens to the permafrost. The permafrost at 3 meters depth, well, this has permafrost, right? This is no permafrost. You got that? Following? That's the surface, right? Look at the top one. The permafrost disappears very quickly. Too quickly. Because by now, which is past this, they have no permafrost left at the top. And you could have that, a little bit of shelter of your shrub. You have forests, even more sheltered. Now they are using sandy soil. Let's look at the real world a little bit. Put some peat onto the sandy soil, right? Just 10 centimeters of peat. Got the difference, right? The red line was when you don't have peat, and then you put 10 centimeters of peat, it's like that. You put a little bit more, which is more natural, like 30 centimeters, and it is like that. So all I can say is peat saves the permafrost, right? I don't have to say more, right? Because maybe when you run the model, you don't go to the field. The computer is always right. Reality is not right if it does not fit the computer model results. You got that? Okay. So the last thing I want to do is to see how you could, you always want to explain, and you always want to conform, right? Whatever other people say, that's called the conventional wisdom, right? What a horrible word, wisdom, right? Conventional is right. Wisdom? I don't know. So I'm sticking my neck out now because I'm going to tell you something which I know nothing about, and I'm relying on the fantastic scientific journal called the Time. Time magazine, you know what, right? Fantastic journal, right? So this is about migration from Asia to America, right? And we all know, if you don't know that, you have not been educated. Maybe that's the best thing, right? That this is how the Indians, the American Indians, come to North America, right? You need the Beringia because it's on Bering Strait, right? And the Beringia happened to be the period when you have a glacial period, when a lot of the water in the ocean go into building the ice, right? And therefore the water level drops down, and therefore there is such a thing as land bridge, which is a horrible place, wet and damp and whatever it is, but it's got attraction, it's got all these fairy animals. I don't mean cats, I mean mammoth and all that kind of things. So the hunters move and so on. That was 12,000 years ago, right? That's what the book tells us. So they migrated all the way down 12,000 years ago. Right? Then look at this fantastic referee journal article from Time magazine, complete with pictures. They found now that in all these places, all the red dots in all those places, there were much older stuff that they found now 30,000 years ago, not 12,000, right? So you could always, oh, but there's another Beringia. Well, why don't you think outside of, as they say, the frame or window or whatever it is, right? Maybe they could swim, maybe they could have a log, maybe they could have a raft, maybe there's something else that could do that, right? After all, some of those Inuits came over from Asia to Arctic Canada by kayaks anyway, right? Well, maybe they could do that. But I'm sticking my neck out, I'm starting some new myths, which I've got the right to do because I'm just joining the gang now, right? So I have some rules for making myths. So basically you have to adore the instrument data. If it's measured, it must be right. Then you have to accept false premises because a premise is a premise. There's no such thing as true or false, it's a premise, right? The moon is made of green cheese, that's a premise. Then the rest is straightforward, right? Because we have logic, deduction, right? So therefore, I know there would be lots of mice in the moon because it's got cheese, right? Then you ignore the physical processes. How inconvenient, just think, how inconvenient, right? You mean permafrost does not melt quickly? How inconvenient, right? So what do you mean peat? I never heard of it. What physical process there is? There's things called insulation, there is the thermal conductivity and so on. Yeah, tedious, boring, right? I didn't take physics long time ago, so ignore that. Model would tell us that, right? And you apply statistics. Make sure it's wrong, because if it's not right, if it's right, it's not attractive. Just look how complicated it is just to draw several lines with a jump and justify it. I could do it with Excel, right? And there you go, I got the answer, right? So just apply the incorrect statistics. Never mind, it should be all right, right? And trust models, have faith. And you got to jump to conclusion. Why do you have to do that? If you publish a paper and you don't have conclusion, the editor would reject you. I guarantee you that, right? Well, on the other side, that's me looking at this. I think there are things which you'll be really very careful about. And there are two things you have to watch out for. One is to love yourself, narcissism. Love thyself, right? Oh, I must be good, I must be great. So whatever I say must be gospel or better than gospel, right? And so on. Avoid that, avoid that. And the other thing is, you love the thing you create. Pygmalion built the model, created a model, and he fell in love with the model. Did I say model? I did say model, didn't I? Right? So if you do that, be very careful, because these things are just like that, right? These are devils we have to avoid, right? So we should take flight from these myths. And that is what I want to say. And thank you for your indulgence in listening to this very poor, not even minstrel without a harp, and spending your hour with me. And thank you very much.